Hi students, we're going to go over the layers of the Earth today. We're going to talk mostly about the lithosphere. So notice that we have, first of all, the inner core. The inner core is solid, mostly iron, very, very high density. The outer core, scientists think is liquid. And then you have the thickest layer of the Earth, which is the mantle. The asthenosphere is sort of like, you could almost think of it like silly putty. It's not liquid, and it's not a very, very hard solid. It's kind of a semi-solid liquid. The lithosphere is mostly what we're going to talk about today, and the lithosphere is this rigid part right beneath the crust, and then the very upper part of the crust that you and I stand on every single day. Oops, hold on. So the lithosphere, again, is the upper solid part of the mantle, and then the upper part of the Earth's crust, which is what we stand on, and it's very, very thin compared to the other three layers. So the rest of the Earth is much thicker. The part that we're standing on is thin, and you can tell that by the fact that we can sometimes see part of the mantle when we look at volcanoes. We can see that liquid rock coming up, which means that the crust of the Earth where we're standing and what we live on is actually pretty thin. So you'll notice that there's two different parts of the content of the crust, okay? You have the crust that's underneath the oceans, which is called the oceanic crust. Notice that the oceanic crust is really, really thin. And that makes sense because if all the crust were the same thickness, then ocean would cover the whole entire crust, but it doesn't. So the crust under the oceans is very, very thin. This is where a lot of movement of the plates is going on. We'll learn about that in the next unit, underneath the Earth's oceans, because they're much thinner. Also, new crust is forming under the Earth's oceans. We'll talk about diverging plates in the next unit. And then notice that underneath the continents, this is where we live, of course we're on the North American continent, the crust is much thicker. This tends to be much denser crust, and this tends to be a little bit lighter crust. So the crust of the Earth is broken into huge plates. We know this, and we know where the boundaries of the plates are by tracking earthquakes. So what scientists have done is they have figured out where earthquakes happen, and earthquakes tend to happen along plate boundaries. So where there are a lot of earthquakes happening, they've been able to sort of trace out where you have these plate boundaries. Notice that we have big, huge plates that actually extend out into the oceans. Okay, so we have the South American plate here, and we have the African plate here, but notice that the boundary between the South American plate and the African plate is right out here in the middle of the Atlantic Ocean. Right out here in the middle of the Atlantic Ocean, these plates are actually moving apart. They're diverging. Notice that the North American plate is, and the Eurasian plate, their boundary is right out here in the middle of the ocean also. And you have Iceland. This little tiny island has this line running right through it, which is a plate boundary that's actually called the Mid-Atlantic Ridge. Notice that right down here, where you have the Caribbean plate and the North American plate, is down in this area where Haiti is. And Haiti and some of those areas, parts of the world, actually get quite a few earthquakes. Okay? So the lithosphere, again, is the crust in the upper layer of the mantle. They make a zone of rigid, brittle rock called the lithosphere. Notice that the oceanic plates are much thinner, and the continental plates are much thicker. That's important when we talk about plate movement. Okay? So, the crust is composed of two different kinds of rocks, mostly. The continental crust is mostly composed of granite. If you've ever been to the Rocky Mountains or you've seen Mount Rushmore, you've seen granite. Granite is a very, very common rock, and we love to carve things out of it because it's really, really hard. Also mountains, a lot of mountains are made out of granite. The oceanic plates are basalt. So, the basalt is much denser than granite. So basalt is much denser than granite, and so therefore the oceanic plates tend to sink underneath the continental plates. Okay, and then the last two things, you're going to be watching this video about the lithosphere, and the next one, you're going to watch the video about the lithosphere. I want to just make sure that you understand a couple of key points again. First of all, the lithosphere is broken up into big chunks called plates. That's very important. The very top of the crust is broken into big chunks called plates. We're going to learn about in the next unit that they think that all the continents at one time were possibly all stuck together. These plates move. Some of them move apart, some of them move towards each other, some of them slide past each other, and that's what's causing earthquakes and volcanoes and some of the different geological things that we see around the earth. Is also causing tsunamis. Okay, hopefully me going over this has helped you a little bit, and I will see you guys later.